In a market full of hype and short-lived trends, few projects manage to stand out for their actual innovation. Kaspa is one of those rare exceptions. While most blockchains race to add layers and gimmicks, Kaspa is quietly rewriting the rules of what a proof-of-work network can achieve. Its speed, scalability, and architecture are challenging long-held beliefs about what's possible in decentralized systems. Over the past year, Kaspa has grown from a niche experiment into one of the most talked about projects in the crypto community. Its approach to solving blockchain congestion through the GHOSTDAG protocol has sparked serious discussions among developers and miners alike. Instead of stacking temporary fixes on old technology, Kaspa rebuilt the foundation, making it one of the fastest proof-of-work blockchains ever created. This isn't just another token chasing price action. Kaspa represents a technological breakthrough that could reshape how we think about scalability, finality, and decentralization. In this video, we'll take a closer look at how Kaspa's unique design works, where it's heading next, and why it might play a major role in the next phase of blockchain evolution. This video is created for educational and informational purposes only. It does not promote or endorse any financial product, investment, or cryptocurrency. All information presented here is based on publicly available sources and independent analysis. Viewers are encouraged to conduct their own research before making any financial or technological decisions. Kaspa has quietly become one of the most talked about Layer 1 projects in the blockchain space. As the crypto world moves between hype cycles of artificial intelligence tokens, new DeFi experiments, and meme coins, Kaspa stands apart for a very different reason: its architecture. It is one of the few projects that has chosen to build on a proof-of-work foundation while still solving the same scalability problems that older blockchains like Bitcoin and Litecoin face. That decision has given Kaspa a unique identity, positioning it as a next-generation network designed for speed, decentralization, and real-time performance. Launched in November 2021, Kaspa is often described as a fair-launched project, meaning there was no pre-mine, no venture capital allocations, and no hidden insiders receiving early tokens. That community-first approach helped the project gain credibility among miners and long-term supporters who value transparency. From the beginning, Kaspa's core philosophy has been simple: build an ecosystem that remains true to the decentralized roots of blockchain, while improving every technical limitation that came before it. At the heart of Kaspa's innovation lies its unique architecture called the block DAG. Most traditional blockchains are linear, where each block is added one after another, forming a straight chain. Kaspa's system, on the other hand, is built on a directed acyclic graph, allowing multiple blocks to be created and confirmed in parallel. This parallel structure enables the network to process a high number of transactions simultaneously without sacrificing security. The protocol that makes this possible is called GHOSTDAG, short for Greedy Heaviest Observed Subtree. Instead of rejecting competing blocks as orphans, GHOSTDAG accepts them all and arranges them in a consistent order. This is one of the main reasons Kaspa can achieve confirmation speeds that are far faster than traditional proof-of-work networks. Kaspa's design is rooted in proof-of-work, using an algorithm called K-heavy hash. This choice stands out in an era where many blockchains are shifting to proof-of-stake models. While POS is often seen as more energy efficient, proof-of-work still offers unmatched security and simplicity. Kaspa's developers believe that combining POW with a modern DAG structure creates a balance between performance and decentralization that is extremely difficult to achieve otherwise. It avoids the centralization risks that can arise in POS systems and keeps the network open to anyone with the right hardware and desire to participate. The results of this architecture are impressive. Kaspa's recent crescendo upgrade increased its block production to around 10 blocks per second, making it one of the fastest proof-of-work blockchains in existence. Most networks struggle with one block every few seconds. Bitcoin averages 10 minutes per block, but Kaspa's DAG allows it to produce blocks continuously and in parallel. The upcoming DAG Night upgrade is expected to push this performance even further, potentially improving transaction throughput, lowering latency, and making the network more resistant to delays and congestion. Technically, Kaspa is designed for scalability at the base layer. It includes features such as pruning, which helps reduce blockchain size over time, and SPV proofs that make lightweight clients more efficient. There are also plans for subnetwork support, enabling the creation of specialized chains or Layer 2 systems that can run on top of Kaspa. The project has also been shifting its codebase from Go to Rust, improving performance, security, and maintainability for long-term growth. These details may sound technical, but they matter greatly. They're the building blocks that make Kaspa stand out from hundreds of other so-called fast blockchains. When it comes to tokenomics, Kaspa is designed with sustainability and fairness in mind. The total supply is capped at around 28.7 billion KS, with roughly 26.8 billion already circulating. Because it was fair launched, there was no pre-mine or early investor allocation, and all tokens are mined through the same proof-of-work process. This means that anyone participating in the network through mining is rewarded fairly for securing the blockchain. The emission schedule is structured carefully so that even with multiple blocks created per second, inflation remains predictable. It's a design that rewards long-term network participation rather than speculation or early access. Kaspa's price action has been volatile, as is typical for emerging projects. Over the past year, it has seen both strong rallies and deep corrections, often driven by community hype around upgrades like Crescendo or Dagnite. While price alone doesn't define success, the growing market cap shows that interest in the project is expanding. What really gives Kaspa long-term value, however, is the combination of strong technology, consistent development, and an engaged mining community. At this stage, Kaspa's ecosystem is still developing. The blockchain itself functions reliably and processes transactions at high speed, but the number of decentralized applications built on it remains limited. That's expected to change as the project integrates smart contract capabilities and Layer 2 support. These upcoming upgrades will allow developers to build DeFi applications, decentralized exchanges, and more complex use cases directly on the Kaspa network. Once that happens, the ecosystem could grow rapidly, similar to how Ethereum's value exploded once smart contracts became widely used. One of Kaspa's most important community efforts is the Kaspa Industrial Initiative, KII. This program aims to push adoption beyond the crypto community and into real-world industries. It supports projects in education, grants, and technical research to help enterprises understand how Kaspa's high-speed network can be used in supply chain management, Internet of Things, IoT systems, and microtransactions. These use cases could demonstrate Kaspa's real-world value far beyond simple transfers of currency. In terms of upgrades, the Dagnite protocol represents a significant leap forward. It's designed to further optimize how the network handles transaction ordering and block confirmation. In theory, it could remove most of the remaining latency between block propagation and confirmation, bringing Kaspa closer to real-time performance. That level of speed could make it suitable for applications that require instant settlement, something few blockchains can truly offer today. When paired with smart contract functionality, this would open the door to a new class of decentralized applications that need both security and speed. Kaspa's move to Rust is another major milestone. Rust has become the go-to programming language for high-performance blockchain projects because it offers memory safety, concurrency support, and efficiency. By rewriting its codebase, Kaspa is setting itself up for long-term scalability and smoother upgrades in the future. It's a forward-looking decision that aligns with the project's overall philosophy. Build for the long term, not just for the current cycle. Despite its technical strengths, Kaspa faces the same challenge every blockchain must eventually overcome: adoption. A network can have the best architecture in the world, but if developers don't build on it and users don't use it, growth will stall. Kaspa's community understands this and has been pushing hard to attract developers and projects. The introduction of smart contracts and better developer tools will be critical milestones. Once decentralized exchanges, wallets, and other applications begin launching, the network's transaction volume and token demand could rise dramatically. From a broader perspective, Kaspa's biggest advantage may also be its simplicity. Many new projects rely on complex governance models, multi-token systems, or centralized validators that complicate participation. Kaspa stays true to the original ideals of blockchain: decentralized mining, open participation, and transparent rules. This makes it easier for new users to understand and for long-term supporters to trust. In a crypto environment often clouded by hype and over-engineering, that simplicity can be a major selling point. There are also economic factors to consider. Because Kaspa uses proof of work, miner participation and network hash rate directly influence its security. A strong mining community ensures stability, but fluctuations in profitability can affect hash power and decentralization. If the token price drops too far, miners may switch to other networks, which could weaken security. On the flip side, if Kaspa's value continues to rise, more miners will join, strengthening the network further. This dynamic makes the ecosystem self-balancing, though it also introduces volatility. Kaspa's roadmap paints a clear picture of where the project wants to go. After the successful Crescendo upgrade, the team is focusing on implementing Dagnite, integrating smart contracts, and expanding user-friendly tools like mobile wallets. The aim is to make Kaspa not only fast and secure, but also easy to use for everyday users. Accessibility is key to mainstream adoption. If users can easily send, receive, and interact with dApps on Kaspa without deep technical knowledge, the network could attract a much larger audience. One area that often gets overlooked in Kaspa's story is its decentralization. Many modern blockchains claim to be decentralized, but rely heavily on small validator sets or centralized infrastructure. Kaspa's mining-based system avoids those pitfalls. Every miner that contributes to the network helps keep it secure, and no single entity can easily take control. This level of decentralization provides not just security, but also philosophical alignment with what blockchain was originally meant to be: open, fair, and censorship-resistant. Still, challenges remain. Competing blockchains like Solana, Avalanche, and Aptos are racing to offer higher throughput and better developer environments. Many of them have already built robust ecosystems filled with active users and applications. Kaspa's focus on proof of work makes it stand out, but it also limits how quickly it can experiment with new features compared to more flexible proof-of-stake systems. The key for Kaspa will be to translate its technical superiority into real-world traction, something that only happens when developers and businesses choose to build on it. From a market standpoint, Kaspa's performance has been mixed but promising. It has experienced significant growth in community size and recognition, and analysts often describe it as an undervalued POW gem. While it may not have the same level of speculative hype as meme coins or AI projects, its long-term fundamentals are stronger. The crypto space tends to reward projects that solve real problems, and Kaspa's focus on scalability and decentralization could make it one of the more sustainable networks in the years ahead. For investors and observers, the most important things to watch are upgrade rollouts, ecosystem expansion, and hash rate growth. If Dagnite launches successfully and developers start building real applications, Kaspa could easily climb into the ranks of major Layer 1 blockchains. On-chain data such as transaction counts, address growth, and mining activity will provide valuable indicators of whether the network is gaining real traction or simply trading on hype. In the long run, Kaspa's vision is ambitious. It wants to redefine what a proof-of-work blockchain can do, to prove that POW doesn't have to mean slow and outdated. Its technology shows that decentralization and speed don't need to be opposites. If Kaspa succeeds, it could mark a new chapter for blockchain design, blending the reliability of Bitcoin's security model with the efficiency and speed of modern architectures. But the path forward will not be easy. Execution risk remains high, and competition in the blockchain sector is intense. Projects with large ecosystems and marketing budgets can overshadow even technically superior solutions. For Kaspa to truly stand out, it must continue to deliver upgrades on schedule, attract active developers, and build an ecosystem that provides real value to users. The potential is enormous, but realizing it will require consistent focus and community collaboration. Looking ahead, the next 12 months could define Kaspa's future. The successful deployment of Dagnite, expansion of developer tools, and growth of decentralized applications could transform it from a promising experiment into a recognized powerhouse. Its strengths, fairness, speed, and decentralization are all in place. What remains is proof of adoption and practical usage. If Kaspa manages to turn its technical edge into real-world relevance, it could very well become the blueprint for what future proof-of-work blockchains aspire to be. In conclusion, Kaspa represents both a technological leap and a philosophical statement. It challenges the idea that proof of work is outdated and shows how innovation can evolve even within traditional systems. With its parallel block production, fair launch, and transparent community governance, it stands as one of the most authentic projects in the crypto landscape. The coming upgrades will test its scalability claims and its ability to attract developers, but the foundation is strong. Kaspa is not just another blockchain chasing trends. It's an attempt to rewrite how decentralized networks operate, combining the old and the new into one cohesive vision. Whether it becomes a dominant force or remains a niche experiment will depend on the months ahead. But one thing is certain, Kaspa has already proven that the future of blockchain can still be built on the shoulders of proof of work. All right? If you learned something new or enjoyed this video, make sure to hit that like button, subscribe to the channel, and turn on the bell icon so you don't miss future updates. Thanks for watching, and I'll see you in the next one.